Welcome to tonight's video on review of trigonometry part 2. Alright, so we'll review the trigonometric function definitions. So if you have a acute angle in a right triangle, so if the angle is in quadrant 1, this creates the right triangle definition, which you guys know as SOHCAHTOA, where sine would be opposite over hypotenuse, cosine would be adjacent over hypotenuse, tangent would be opposite over adjacent, cosecant would be the reciprocal, would be hypotenuse over opposite, secant's the reciprocal of cosine, hypotenuse over adjacent, and cotangent is adjacent over opposite. That's only if it's a right triangle. If it's a general definition, meaning if it's more than 90 degrees, so let's say you went into the second quadrant, right? Now theta is in the second quadrant. Let's say you knew a point on the terminal side, the x and y. The distance between the origin and the point we'll call the radius. So you could draw a reference triangle, right? So this would be y and this would be x. So the sine is really y over r. The cosine is x over r. And the tangent is y over x, where those denominators can't equal 0. The cosecant is the reciprocal. The secant is the reciprocal of the cosine. Cotangent is reciprocal of the tangent. Alright, to find the radius, you do the Pythagorean theorem. It's the square root of x squared plus y squared. So that's the general definition. The unit circle definition occurs if the radius is equal to 1. Then, using the general definition, it's just the sine is y, the cosine is x, the tangent is y over x. The cosecant is 1 over y, secant 1 over x, and cotangent's x over y. That's if the radius is equal to 1. So then, looking here, if it gives us a point on the terminal side, -3, -1, to find the radius, we take the square root of x squared plus y squared. So it's going to be 9 plus 1, so the square root of 10. And then this is our x and y. So remember the sine is y over r, which means it's -1 over the square root of 10, which you could rationalize to negative square root of 10 over 10. The cosecant is r over y, so it would be the square root of 10 over -1, which is negative square root of 10. Cosine is x over r, which is -3 over the square root of 10, which is -3 square root of 10 over 10. Secant is r over x, which is the square root of 10 over -3. Excuse me. Tangent is y over x, which is -1 over -3, which is 1/3. Cotangent's x over y, which is -3 over -1, which is 3. Alright, so the next one, you take the square root of -4 squared plus 0 squared, and you'll get that that's square root of 16, which is 4. So the sine would be 0 over 4, which is 0. The cosecant would be 4 over 0, which is undefined. The cosine would be -4 over 4, which is -1. The secant would be 4 over -4, which is still -1. The tangent would be 0 over -4, which is 0. And the cotangent would be -4 over 0, which is undefined. Now for number 3, the square root of 0 squared plus 3 squared, that's the square root of 9, which is 3. So the sign is y over r, which is 3 over 3, which is 1. The cosecant is 3 over 3, which is also 1. The cosine is 0 over 3, which is 0. The secant is 3 over 0, which is undefined. The tangent is 3 over 0, which is undefined. And the cotangent is 0 over 3, which is 0. Now for number 4, when we take the square root of negative 5/13 squared plus negative 12/13 squared, that gives us the square root of 25 over 169 plus 144 over 169. Basically, it gives us that the radius is 1, because it's 169 over 169. So that means it's a unit circle definition, which means the sign is just the x value, or the y value, which is negative 12/13. The cosecant is the reciprocal, which would be negative 13/12. The cosine is the x value. The secant is the reciprocal. The tangent, you're going to take negative 12/13 divided by negative 5/13, which means you're going to get 12 over 5. And the cotangent would just be the reciprocal of that, which is 5 over 12. So then for number 5, the square root of negative 3/5 squared plus 4/5 squared, that's also going to give you 1. So it's a unit circle, so the sign is 4/5. The cosecant is 5/4. Cosine is negative 3/5. Secant is negative 5/3. Tangent is 4/5 over negative 3/5, which is negative 4/3, and the cotangent would be negative 3/4. The last one, when you find the radius, the square root of 3 over 2 squared plus negative 1/2 squared is also 1. So the sign is negative 1/2, the cosecant is negative 2, cosine is square root of 3 over 2, secant is 2 over the square root of 3, which is 2 square root of 3 over 3. The tangent is negative 1/2 over square root of 3 over 2, which is negative 1 over the square root of 3, which is negative square root of 3 over 3. And the cotangent would be negative rad 3. What is special about problems number 4 through 6? The radius is equal to 1, so you would use the unit circle definition compared to number 1 through 3 where you use the general definition. All right, reference angles and reference triangles, like if you have an angle in the second quadrant, and we talked about this earlier, right? There's an angle in the second quadrant, theta. Here's pi. Here's your reference angle, and then you draw your reference triangle to the x-axis. So to find the measure in degrees, this is also 180 in degrees, you go 180 minus theta. In radians, you go pi minus theta to find the reference angle. In quadrant number 3, there's theta. Here's theta prime, the reference angle. So notice now, because this would be 180 or pi, now you're going to subtract the angle from 180. So it's going to be theta minus 180 or theta minus pi. In the fourth quadrant, because remember, you go to the x-axis, So here's your triangle. Here's theta prime. This is 2 pi or 360. So you're going to go 360 degrees minus theta to give you the reference angle, or 2 pi minus theta. And last but not least, in the first quadrant, the angle and the reference angle are exactly the same. Well, how does that help us? Well, if you look at sine 5 pi over 6, 5 pi over 6 is in the second quadrant. So if you draw the reference triangle, this is pi minus pi over 6, or 5 pi over 6, which is pi over 6, which is 30 degrees. So remember the 1 rad 3, 2. So the y is 1, and the r is 2. And since it's in the second quadrant, it's positive. Remember, all students take calculus to remember whether the trig functions are positive or negative. In what quadrants? Cosine 135 is also in the second quadrant. Now 180 minus 135 gives us 45, and that means it's a 45, 90, which means the x is 1, the hypotenuse is rad 2. If you rationalize it, you get rad 2 over 2, or the r is rad 2. And since it's second quadrant, it would be negative. 5 pi over 3 is in the fourth quadrant. So here's your reference triangle. So 2 pi minus 5 pi over 3 is pi over 3. That means it's 60 degrees, which means it's square root 3, 1, and 2. So when you do y over x, you get the square root of 3 over 1, which is the square root of 3. And tangent is negative in the fourth quadrant. So here's a summary of the identities. Pay special attention to the Pythagorean identities, the quotient identities, the reciprocal identities. Notice eventually we'll use for equations the double angle identities. But yes, it might be a good idea to make some flashcards and to memorize these. There's something you should know. We will use these identities to prove trig identities, basically like proofs. And the rules are you pick one side to work with, and then you use these techniques like factoring, combining fractions, splitting fractions, multiplying by the conjugate. So pick a side. So here I'm going to pick the left, and I rewrite it, and I say equals. Okay, so my goal is to break down the left side so it equals the right. Remember, everything can be written in terms of sine and cosine, like cotangent is cosine over sine. Tangent is sine over cosine. Getting a common denominator would give you cosine squared plus sine squared over sine times cosine. Cosine squared plus sine squared is 1. And then remember, you can split up the fractions. So 1 over sine times 1 over cosine. And that is the same as cosecant times secant. And that is the same as what you are trying to get. All right, number 2, for some reason, it's the same thing. Number 3, it'll be easier to work with the left. So we'll say cosine theta cotangent theta over 1 minus sine theta minus 1 equals, well, when you multiply, let's simplify this part first. So cosine over sine for the cotangent, 1 minus sine. So cosine times cosine is cosine squared. And cosine squared is the same as 1 minus sine squared. And then if you factor this, 1 minus sine squared is the difference of two squares. And when you divide fractions, you multiply by the reciprocal. So you're going to times it by 1 over 1 minus sine. So that, notice, these will cancel. So you're left with 1 plus sine theta over sine theta minus 1. And getting a common denominator allows you to cancel the signs. So you're just like 1 over sine theta, which is cosecant theta. It's a process. All right, then here, so with this one, it doesn't matter which side you pick. Let's say we picked the left side. So we have 1 plus sine theta over cosine theta. Now, nothing can simplify, so when that's the case and you have an expression, multiply by the conjugate. So multiply by 1 minus sine theta. So you get 1 minus sine squared over cosine theta times 1 minus sine theta. 1 minus sine squared is the cosine squared. And then notice 1 cancels. So it's cosine over 1 minus sine. There you go. All right, the last one here. Cotangent squared times, cotangent squared over 1 plus cosecant. All right, so for number 5, if we start with the left side, we get cotangent squared over 1 plus cosecant equals, and so cotangent squared is cosecant squared minus 1. When you factor cosecant squared minus 1, well, let's do it this way. Okay, so here we can factor, and we get cosecant minus 1, cosecant plus 1, because it's a difference of two squares. And then the cosecant plus 1s cancel out, so you're left with cosecant minus 1. Well, we can't really do anything else, but what we can do is say, okay, what if we worked with the other side? So let's say we said cotangent theta times secant theta minus tangent theta, and said, what would that equal? Well, cotangent theta is cosine theta times over sine theta times 1 over cosine theta minus sine over cosine theta. So basically it's cosine over sine times 1 minus sine over cosine. So we get 1 minus sine over sine. We might say, well, how is that the same as cosecant minus 1? Well, if you split the fraction, you get 1 over sine minus sine over sine, which is the same as the cosecant minus 1. Notice they are the same, so we're able to break it down and work with one side first, get it to a certain spot, and then work the other side and get that to a certain spot. So therefore they are equivalent. Yes, that is possible. Normally I would say just work with one side and get it to the other, but when you can't do that or you get stuck, you can do this where you work with one side, get it to a spot, work with the other side, get it to a spot, and then they are the same. All right, that concludes our video for this evening. If you have any questions, I'll see you in class. Have a good evening.